Hi, Prof. I am Yoi Kang, Nomenclature A22A0628. I'm going to present my article report, which is a green vehicle routing problem, GVRP, a state-of-the-art review. Next, introduction. GVR is a refinement of the classical vehicle routing problem, which includes avoidance of fuel consumption, emission reduction, and route planning for non-petrol driven vehicles. The green VRP built upon the classical VRP by integrating ecological and sustainability objectives into its optimization process. Hence, the design and use of sustainable automobiles or green vehicles have increased widely in effort to reduce the negative effects on the environment. Green vehicles like electric vehicles, hybrid electric vehicles, plug-in hybrid electric vehicles, and fuel cell vehicles have been introduced to replace conventional internal combustion engine vehicles because of the less emission they offer. The primary issue and problem highlighted in the article is the environmental impact of transportation. Transportation is a major contributor to global greenhouse gas emissions, particularly carbon dioxide (CO2). Also, one of the environmental concerns is the inefficiency using vehicles routings. A few logistical systems do not consider traffic patterns, topography, or the number of stops on the route, which negates the impacts of fuel consumption and emissions. An additional issue and problem discussed in the article is the absence of consolidated practical classification of green VRP variants. The GVRP contains multitudes of vehicles and environmental objectives. However, they all are lacking in organized approach to framework that would allow modeling them comprehensively. That pose several problematic issues, which are different types of vehicles with different demanding specifics. Thirdly, the issue and problem highlighted in the article is lack of systematic reviews. As the article explicates, although many papers tackle different elements of green routing, there is an absence of systematic reviews that synthesize these studies according to basic constructs such as problem types, solution methods, vehicle technology, and environmental goals. The methodology suggested for resolving of the green vehicle routing problem is mathematical programming. The approach used in mathematical programming deals with capturing GVRP using precise mathematical expressions. Typical methodologies are linear programming (LP), mixed integer linear programming (MILP), and nonlinear programming (NLP). The second methodology that suggested is meta-heuristic algorithms. Complex GVRP problems that require approximation solutions include genetic algorithms, GA, and colony optimization, ACO, double search, TS, simulated annealing, SA, and particle swarm optimization, PSO. However, the third methodology suggested is simulation models. Simulation models assist in examining the behavior of green automobile routing edge within analyzing different conditions. These models often simulate vehicle movement, refueling patterns, or emission outputs with greenhouse gas in a virtual space. Moreover, the fourth methodology suggested is hybrid methodologies, which integrate two or more methodologies to take advantage of their strengths and minimize their weakness. Regarding GVRP, it is highly recommended to integrate environmental issues into routing decisions which require modification of approach functions to emission targets of CO2, NOx, fuel, and others of concern. For example, the company might incur additional costs or more time in delivery but in exchange for less polluting routes. Secondly, it is recommended that the use of alternative fuel vehicles. Fleet and logistic managers need to begin shifting to the use of alternative fuel vehicles, which incorporates electric vehicles, hybrid power vehicles, and vehicles using compressed natural gas or hydrogen. Thirdly, it is recommended to develop advanced solution techniques, apply meta-heuristics, genetic algorithms, and colony optimization, simulated annealing, and double search. For greater GVRP model reliability and accuracy, it is recommended to incorporate dynamic and stochastic elements into routing decisions. This involves integrating real-time information supplied by GPS, traffic surveillance, and IoT sensors to facilitate constant updates of vehicle routes. To summarize, the green vehicle routing problem admits for significant development in the transportation and logistics fields. There is great potential within green VRP, accompanied with constant need of new ideas, policies, support, teamwork, and change if the balance is to become real. So that's all my presentation. Thank you, Prof.